thing that I'm going to do today is not a regular talk. It's not the story that I want to tell. To be brutally honest, I didn't really prepare for this session as I would do a normal session. I just want to share some of my experiences from the past few months, basically by building some .NET applications at my home that can help me with all of my IoT stuff. My wife is very happy with that because I can also make her life easier by building a couple of things at our home. So she's very happy, but she doesn't want to listen to me talking about how I did it. So that is why I'm here talking to you. So, very, very quickly, my name is Johnny. I'm from Belgium. I took a very long train ride yesterday, 2.5 hours, all the way to here. But the only thing you really need to remember from this is that everything that I show you today is available on my GitHub. So everything that I've built for my home is freely available on my GitHub. You can look at it. You can do whatever what you want with it. The link is on this slide and that QR code. And with that, I'm just going to talk to you through the things that I did. I am a .NET developer. I've been a .NET developer for almost 20 years. I'm mostly these days an architect and a backend developer, so I don't do a lot of front-end. But of course, I'm a geek, like probably a lot of you guys. I like to play around like a child with the technology that we have today, and I like to learn from that and, of course, share those experiences with you. So maybe one final thing before I start. Yes, I know about Home Assistant. Shut up about it. I just wanted to try my own thing. So I know about Home Assistant, but this talk is not about Home Assistant. This talk is basically about building the things without Home Assistant with the technology that is .NET. I just wanted to do everything in .NET. So yeah, at the end of the talk, if you have something like, you can do all of that stuff with Home Assistant, I know. Don't worry about it. Sometimes I want to reinvent the wheel. So, this story begins a couple of years ago, before I talk about my car. I live in a quite small home in Belgium, a home in a row of houses with like small gardens in the back. And my wife decided to buy a sauna because we like to relax. So we bought a sauna. And then when the sauna got installed, this is what I saw. So the sauna is downstairs outside of my home. This was the user interface for my sauna, which it's not really visible, but in the top there's a very small segmented LCD display. Doesn't really look 2025 to me. And also there's no IoT things available. So I don't have an app. I have no idea what the sauna is doing. When I'm sitting inside, again, I'm a developer, I'm lazy. I want to know these things while sitting in my seat. So I looked at the electronics, how it worked, and it's actually pretty simple because a sauna is just a heating device, and you can turn your heating device on or off. There's two relays. There's a small one and a bigger one. The bigger one is 3-phase. The smaller one is single-phase. One is for the heating. The other one is for the infrared panels. So that's what I needed to know. And then in the top, there's a couple of colored wires that go to that circuit board. They are basically for measuring temperature and for turning on those switches on and off. So I introduced a Raspberry Pi into this system. I just disconnected those wires, connected them to my Raspberry Pi, wrote a couple of .NET applications to basically do that for me. And then that is basically why there's a little sticker on the top and on the bottom here. I just took an Android tablet, put a MAUI application on that, pasted on top of the original display, and now I have a modern sauna. I have a modern sauna with an application on my phone. My wife has an application on her phone. When we're somewhere out hiking, we can already turn the sauna on, and then we can drive home, and when we get home, the sauna will be at temperature, and I can really relax without the need to wait. So this was the first project that I did, which, as I said, made my wife quite happy, and which basically started this whole process of building all of these home IoT applications. All right. Now, the years went by. And basically, you buy a lot of crap. You buy a lot of crap, and all of the crap these days has its own little application. So I have my solar panels, which have their application from SolarEdge. I have some interactions with my power usage from HomeWizard, which is a Dutch company, I think. Then I have an application from Remea, which is also a Dutch company, I think, that does my heating. I've got some Shelly devices for my smart plugs. I've got my car, which has its own application. And of course, I have my own sauna application. And I'm really sick and tired of using all of these applications one by one. I want to basically integrate them in one big application. And that is what I did. So I'm not going to show you more slides. I'm just going to show you the end result, if I can find it here. So I built the My Home application. It already exists for quite some time, and you will see it's not the most beautiful application. This is basically me playing around with Blazor because I'm a backend developer. I really didn't do any front end these past 10 years. So I tried some Blazor. And the idea was I need to get all of that data from those different applications, and I need to consolidate them in one single application. So basically, I have a tile for my electricity usage. This is, by the way, this is not a print screen. This is live data, so we can see what my wife is doing at home. So this is power usage. This is everything solar related. This is my heating. So yeah, my wife, 23 degrees at home. She likes it quite warm and cozy. Here's my car, which is parked at home because I came by train. And then there's my sauna, which is off. So my wife is not in the sauna right now. Okay, how did I do this? Well, first of all, you need to check all of those applications. Some of those applications, like for example, Tesla, they have their own API. You can actually use their API, and you can call the different endpoints on their API to get information about your car. You can even send commands to your car to do all kinds of cool things, which is cool. Some of these companies, they will do that. They will provide an API, so if you have an account, you can use your account to authenticate and then use their API to basically get your data, which is nice. But most of these applications, they really didn't. So I needed to figure out how to do that. Some of these applications have a website, a web interface. You can basically do F12 in your browser and check which endpoints that they are calling in the background and then just work from there. And other ones have Android applications. So let me try to show you, for example, here. So I have an Android emulator running right here. And there's an application from SolarEdge, which is the vendor that has provided me with my solar panels and my home battery. If you open Fiddler, for example, Fiddler is an application that basically creates a proxy, and this proxy listens to all of the HTTP traffic that goes through it. So now it's basically sending all of the HTTP requests on my machine through the Fiddler proxy, and I can really see what is happening. So if I open my Android emulator, and if I try to open my SolarEdge application, you can now see in the endpoint list a lot of these API/SolarEdge things happening. So if we pause this, and if we browse those endpoints carefully, one by one, some of them are useful, some of them aren't. So for example, here you can see a JSON being returned, consumption, current power equals 0.51 kilowatts, probably, so 500 watts. So this is already useful information. So this is basically what I did. I looked at all of those applications, or when they were running on Android, you can do it like this, or when they run in your browser, you can just use your browser development tools to get that information and basically create your own client for those endpoints. The only difficult part here is that most of those communication is encrypted. It's using HTTPS, so you need to do some little trickery there. Basically, when you look at Fiddler, it will tell you the IP address of its proxy. So if you use that IP address and you put that into your Android device and tell your Android device to route all the traffic through that specific address, then it will go through the Fiddler proxy, but then it's still encrypted. But now you can browse to that IP address on your Android device, and you can download a self-signed certificate from Fiddler, and you can actually use that certificate if you trust it on your Android device, and then basically it will encrypt that traffic with that fake certificate instead of the actual certificate. And then Fiddler is able to decrypt that traffic, because now you're using the Fiddler certificate to actually get that traffic readable, which is quite nice because now you have all of the information. The thing that I noticed is that for SolarEdge, for example, when you download their newest application, they use certificate pinning, which actually means that they have their own certificate pinned inside of their application, and they only trust their own certificate. So if you use another certificate for that, even if you trust it on the Android device, the app will not trust it, so the app will not work anymore. So I basically installed an older SolarEdge version of the application that didn't have that in place yet. So sometimes you're lucky, sometimes you're not. But for most of these applications, this is the way that I did it. For example, my heating, for the Remea app, they only have an Android app, so I used that Android app and basically listened to all of the traffic, and I can send commands. I can turn on my heating, turn off my heating, change my heating schedules, just by using the same endpoints as their app uses. You just need to look at how it's authenticated, basically do the same kind of authentication flow. They were using OAuth, so I'm just also doing OAuth in the backend, and then when I got a token, I can use that token to call all of those endpoints and bring all of that data nicely together. So, looks simple. Now you know how it works, so you can also do something similar. Okay, then what is fun about this? Well, if you look at the solution, I basically gathered all of that information, and I've created a project called myhome.integrations. And in myhome.integrations, I've put everything in a separate folder, so I have everything related to my heating, everything related to power, sauna, solar, car, and my smart plugs and smart lamps. The idea is the same for all of these things, so there's always a service, so there's a solar service, there's a sauna service, there's a power service, there's a heating service, and so on. Now, with that information, let's, for example, take the solar service. I can create methods that get the total overview, get the battery level, get the energy overview, get the energy today, get the energy this month, and so on. They, in most cases, just use those endpoints that I just show you that basically come from the apps. But there's different ways. For SolarEdge specifically, not everything is available in the application, unfortunately, because I also have a home battery at home, and the home battery has a lot of logic that just runs internally, and I can't really get that information or change the behavior of my home battery using the application, because the vendor, SolarEdge, does not support this, but my inverter supports it. So I found something which is, if I can open my browser. So for SolarEdge specifically, there is something called Modbus. They implemented Modbus over TCP, which is basically a protocol that you can use and just talk through TCP to your inverter. And they basically explain everything in this technical note based on the SunSpec specifications. And if I scroll down, they just have a long list of addresses, what kind of data is at that address, and what that data represents. So now I can also get a lot of that information directly from my home battery, just on my local network, without the need for these external applications. So this is also something that I completely tried to figure out. I wrote a little NuGet package for it. It's not yet ready. I mean, it works, but it's not production ready for everyone. But the cool thing that I do with that now, for example, I don't know if you know, but in Belgium, we have politicians, and those guys are assholes, which means that because a lot of people have solar panels in their home. A lot of people are also pushing energy onto the net. I think you have the same problem here in the Netherlands. And in Belgium, there's one additional rule that if you take more than 2.5 kilowatts of energy from the net at a specific time, they will tax you for that because you have a peak, you use a peak. And they put the maximum at 2.5 kilowatts. If you go over 2.5 kilowatts, they will basically bill you a specific amount. If you go above 5 kilowatts, they will bill you even more in blocks of 2.5 kilowatts. Now, the problem with that is they will look at that each month. And if there's one specific moment in the month, in the whole month, that you go over 2.5 kilowatts, you went over 2.5 kilowatts, so you pay full price, which is a shame. But I have a home battery. I asked SolarEdge, can you help me with that? Can I, for example, charge my battery during the night period when tariffs are cheap? And then during the day in the winter, I can use my battery instead of taking things from the grid. And they were like, that is technically possible, but we don't offer that within the application or within our software. So I tried to find it myself, and I found it. So basically, I can now tell my battery during the night, please charge yourself with this specific amount of energy, because by default, it will just take the full 5 kilowatts, which is not what I want. So now I charge it at 1.7 kilowatts during the night as long as I can, so that in the morning it's charged, and then I can actually use that energy, and I never go over my peak. So if you go back to the actual My Home application, this is also something that I'm showing you here. This is the peak power, which is now 0.4 for this entire month, so for March specifically. So I'm always using my battery power instead of the grid power by charging it at night. Well, basically the past few weeks have been quite sunny, so I didn't really have to charge my battery during the night, but fine. So these things all helped me to basically circumvent, and that's basically what the government wants. The government wants that we spend our own energy and that we don't use the grid's energy basically to keep the grid stable. So I succeeded, and I had a little bit of fun with that. The other thing that I basically did was charging my car. And that's the thing that I wanted to talk about today. So, as I said, I live in a small home. I don't have my own driveway. I just have the street in front of my home. So my car is always parked in the street, and I don't have any way to charge my car easily. There's a couple of charging points near, and those are listed here. So I have one at a couple streets one direction, and I have one couple of streets the other direction. I can now see, again, the live data, but just looking at a random app, getting the endpoints again, and using that information for myself. So I know that 2 out of 2 are free on the left-hand side of my home, and 1 out of 2 is free at the right-hand side of my home. Now, but what I also did is, because in the summertime, and I can actually show you this in the app from SolarEdge, during the summertime, I have a lot of excess energy that I basically don't use. So if I go back to, let's try to remember, I think August 10 last year, fuck's sake. That's what usage in the summer can look like. So if you look at colors, so the blue colors on the bottom is basically what I'm using. So not a lot in this way. I think this is 9:45 in the morning, so this is just making coffee. And then the rest of the day I didn't do anything. And then on the top-hand side, you can see solar power in green. And basically, the dark green is the part that I'm actually using, and the lighter green is my battery charging. And then at this point in time, around noonish, you can see that it stops charging my battery. Why? Because my battery is full. So what am I going to do with that remaining power? Well, I'm going to sell it to the grid. So this light blue part is basically selling all of that energy to the grid. In Belgium, that will get me 0.02 cents per kilowatt hours, which is Nothing. So what I decided to do, decided to basically, when I plug in my car, just in my home, I want to create something that is smart enough to basically only put my excess solar energy in my car. And so this is what I actually did. This is August 10. Then I had an idea. I told my wife, shut up, I want to do this little thing. Go to August 11, and this is what it now looks like. So on August 11, we had the same kind of thing. Like the battery doesn't get quite low because we're basically living outside in our garden. It's nice weather. I'm not going to sit inside, except the night before to write this little script. And then when my battery is charged, I'm not going to put my solar energy on the grid. No, I'm going to put it in my car. And now you can see here that I'm using all of that energy in dark blue. And there's a little margin left that I'm still putting on the grid because I want to be safe. I'm going to put as much as I can in my car, but not everything, so that I always have a little margin. And it is actually because I already had all of those information. I can already have access to all of that data. The only thing I need to do is be smart with that data. So inside of the My Home application, I created a worker service. So a worker service in .NET is a service that runs in the background, and it runs in a Docker container on my local network. It runs continuously, and it continuously looks at what is happening with my power usage. It's continuously looking at what is happening with my car. So let me get these out of the way. So this is an infinitely running loop. And in that loop, it's going to use what I call a car charging helper. And the car charging helper is the one that's going to really look at, should I charge my car, yes or no? And this actually runs every 5 minutes when my car is not plugged in. And then when I plug in my car, it changes to every 10 seconds. And then when my car is actually plugged in, every 10 seconds, this little piece of C# script will run. Now, if I look at that car charging helper, it's not rocket science, it's super simple. What does it do? It looks at a couple of things. Is the location of my car home? This is something that I can ask using the Tesla API. I can ask where's the car located, and you can specify, like, if it's in a radius of this around this specific location, then it's called home. So I know that it's just sitting in front of my house. And when the charge port is open, I know that it's plugged in, because if you don't have anything plugged in your charge port, it automatically closes. So when it's open, I know it's plugged in. And then if that is the case, my car is ready to charge. I ask my solar service, get me an overview of all of your solar power. And then it's going to, for a couple of minutes, it's going to collect solar power and consumed power. So I'm going to take an average. I'm not going to do it every 5 seconds. I'm just going to take an average over a range of about 2 minutes. And when that happens, when I basically have enough collected samples to have enough samples to collect, I'm going to take an average of the solar power that is available and the power that I'm currently consuming. And based on that, I can start calculating. So I know that if the car is charging, that it's already charging based on a couple of amps. I can calculate how much power that is using, and then I can calculate the remaining power that I basically have from my solar energy. And from this, I can go back to the maximum possible current that I can use right now. And if I have that number, I can check. If my home battery is charged more than 95%, my car is not charging, or my car is charging, but it's not charging at the calculated amps that I've basically now calculated, then I'm going to call a method called carCharging.startCharging based on a couple of amps. So if I calculate, for example, I have 16 amps available, then I can just send a command to my car, start charging at 16 amps, and it will do that immediately. Else, if my battery level is less than 95%, or my maximal possible current is lower than 2 amps, I'm going to stop charging. And that's it. So now, the only thing that my car will do is, based on the solar energy, in this case it was a very, very clear day, But if, for example, a cloud goes by, the charging amps immediately go down, my car charges less, and then when the cloud has disappeared, it goes up again very quickly. And it always very nicely follows this curve. I had some fun, and I didn't have to pay any money for some company to install a home charger, because probably next month they go bankrupt, and I need to find something else to fix that. Now, why the fuck am I talking about AI in my title then? Well, everyone was talking about copilots, and I was a little bit skeptical about AI, or at least Gen AI, because Gen AI is very, very cool. It allows you to talk to a large language model, for example, and that is, I agree, it's pretty amazing. But if you just purely look at a large language model, it's just that. It's just a model that is able to do language, but it doesn't know anything. So if I talk to ChatGPT, for example, it will tell me stuff, but it's not per se true what it tells me. So that's why I was a little bit skeptical. But then I saw things about semantic kernel, for example. I've seen there's a lot of talks today about semantic kernel, and I also tried to look into semantic kernel, and I basically implemented semantic kernel into this project, and now I can ask the large language model all the questions about everything that you see here, and even things that you don't see here. So for example, I can ask questions like, what is the current temperature in my home? It will tell me that it's 23 degrees. So I can now use a large language model to combine real-time data with a language model. So I can talk to this copilot, and the copilot can actually get the information reliably from my application, and I will show you how. But first, let's do a couple of more examples. I can ask questions like, will there be enough solar power to charge my home battery tomorrow? Question mark. The solar energy forecast for tomorrow is 5.8 kilowatt hours. The maximum capacity of your home battery is 9.7 kilowatt hours, and based on the forecast, the solar power will likely not be enough to fully charge your home battery tomorrow. So now the large language model basically got multiple amounts of information, because now it fetched the fact that tomorrow there will be 5.8 kilowatt hours of solar power. By the way, this is a free service you can use. It's solar.service. It's a website that has an API available, and from that website you can call an endpoint, and you can specify specifically where you are located, how many solar panels you have from what specific power, with what specific power output, and what the angle of the panels is, and how they are located towards the north or the south. And if you get all of that information correct, it pretty accurately shows you what tomorrow, the day after, and the day after tomorrow will give you for solar power. So this is also what I use to charge my home battery at night. So I basically look at how much solar power is there going to be tomorrow, and based on that number, I will charge my battery less or more, depending on what is going to be next. This information is then enriched with the fact that the large language model knows that my home battery has a capacity of 9.7 kilowatt hours, and based on that, it does, of course, its little fancy calculation. So very quickly, I will show you semantic kernel, and then I will show you how I've implemented this inside of my application. So I've created a very small example here. Let me first very quickly run it to show you what it does. It's a very simple chatbot, which is what I created in the My Home application. The user can ask a question, for example, who is Frans Bauer? And then, of course, the assistant should answer with who Frans Bauer is. I'm sorry, that's the first Dutch singer, whatever, that I could think of. So it works. And how does that work? Actually pretty simple. Who has never looked or worked with Semantic Kernel before? Okay, most of you, so you will learn something. So Semantic Kernel is a package from Microsoft that basically helps you to talk to a large language model. And they've created a whole SDK around that to make it easier for you to talk to different kinds of large language models. So basically, you can talk to Azure OpenAI, you can talk to OpenAI, or you can talk to other open source models. And it has some additional functionality also, so that you can create your own agents, you can create your own multi-agent systems if you want. So it's really helpful for you to very quickly get to work with these large language models. So the thing that I did is I need to create a kernel. And the kernel, it's based on the methodology in .NET. In .NET, when you create a web application, for example, you create a web application by using a web application builder. So for Semantic Kernel, you create a kernel using a kernel builder. So the concept is the same thing. And then you're using extension methods to extend the kernel with functionality. In my case, I'm going to extend my kernel with access to Azure OpenAI. And for Azure OpenAI, I need some configuration data. I need the name of my model, which I'm using GPT-4o. I need to use the endpoint for my specific OpenAI endpoint, and then, of course, my private API key. Then I'm going to build my kernel, and I'm going to create what is called a chat completion agent. So a chat completion agent is an agent that, of course, you can use to chat with, and it will complete. When you ask a question, it will give you an answer. You give it a name, you give it the kernel, and you start a chat history. A chat history is a list of the messages that you have been sending towards the large language model and the answers that the large language model sends back to you. The history is quite important because a large language model is stateless. So when you ask a question, it answers your question, and that's it. It doesn't store your state. So if you would ask a follow-up question, it can't answer that follow-up question because it already forgot your initial question. So the way that works, it's the same with ChatGPT Online, for example. If you send a question, you get an answer, and you send a follow-up question, you need to send the original question with the answer from the large language model with that request. So you basically need to send the whole context over and again so that the large language model knows the whole content. So the longer this history keeps going, the more expensive it gets because the longer your question basically becomes. So in this case, I'm going to run this in a while loop, and I'm going to ask for the user to ask a question, and then I'm going to add that to the history as a user message because it's a message that the user has asked. And then the assistant is going to respond. So you can call a method called invoke async on your chat completion agent, send the history with that request, and then the large language model will asynchronously stream to you the result. And then, of course, when you have that result in full, you can also add that to the history as an assistant message. So now you have user messages and assistant messages. And this just keeps going on and on forever. So this is the bare basics of what Semantic Kernel can do for you. You can basically create a chat client where you can go back and forth between a large language model. But this does not make it intelligent. This is still just you talking to a large language model, and it just sends words back to you. There's no real intelligence there. The way to add intelligence to that is by adding what we call plugins. So if I undo my changes here, there's a couple of things that I've added now. I've added this little thing, builder.plugins.addFromType. So I've created a class called general plugin, and I'm going to show you what's in there in just a moment. This will give the large language model access to a little piece of my application. Then I've extended the chat completion agent by giving it a description and some instructions. And the instructions tell it that it should only reply on questions related to the current date and time. This is just for demo purposes. So that I can ask the large language model, like, what is the current date or what is the current time? And then in the arguments section, you have something called a tool call behavior. auto-invoke kernel functions. This basically means that if you ask a question to the large language model and the answer is not in the large language model itself, but the answer is in my application, then it will automatically invoke those functions within my applications to get the actual data from that. And again, I will show you this in more detail later. The rest of the application stays the same. I'm just going to do a chat, I'm going to send user messages, and I'm going to receive assistant messages from that. Let's first put this little thing in comments. The functions itself is basically a class with a couple of methods. And in this case, I have two methods. I have getDate and getTime. And on top of these methods, you put a kernel function attribute and a description attribute. So now what is happening? So when you ask a question to Semantic Kernel, using Semantic Kernel to your large language model, with that question, we are going to send some metadata. And that metadata is going to contain the plugin. And the plugin, in this case, is called the general plugin. And the general plugin contains two functions. And those two functions are getTime and getDate. And the descriptions that you provide with those functions basically tell the LLM, look, these are functions that you can call, and when you need to call those functions, basically this is the description that you need. What does that mean? It means that when the user asks something that is related to the description, the large language model is going to be smart enough about that and is going to know, okay, I need to call those functions and I don't need to make up my own story here. So when I ask get the current time, I'm sending get the current time to the large language model, but I'm also sending the fact that these two functions exist. And then the large language model looks at my question, it looks at those functions, and it correlates. It's like, okay, your question needs to call this function. So the large language model goes back to me, not with an answer, but with, dear sir, please call this function and provide me with the result from that function. So I need to go back to the large language model with the result from that function, and then the large language model will create a natural language response using that data. So basically there's a back and forth that you need to do, and this is where the Semantic Kernel package helps you, because you as a developer don't need to do that back and forth. You just need to specify your functions. Automatically those functions will be sent as metadata to the large language model. Then the large language model goes back and forth with Semantic Kernel. And then when it gets all that data, it will send you the final end result. So if I run this application, and if I ask the question, what time is it? It will answer, it is 4:22 p.m. Because now it has access to that real-time data. By the way, if I wouldn't use the functions with this, I didn't show you, but the last time that I showed you, that I tried this without the plugins, when you ask a large language model what time is it, it will tell you I don't have access to real-time data, and then it's a little bit passive-aggressive about it, and it tells you, please look around, maybe there's a clock somewhere. So in this case, now it has access to that data. And you can even see what's happening by just putting a breakpoint. If I put a breakpoint in my getData method, or getDate method, and I'm asking like, what day is it today? It hits my breakpoint, because now the large language model knows that it needs to call my function. It asks Semantic Kernel, please call that function. Semantic Kernel calls my function, returns the result from that function back to the LLM, and then the LLM actually creates its result from that, and it tells me today is Thursday, 13 March 2025. There's one additional thing that I added. It's a little debug method, because the history, so the list of historic messages that you keep, actually also keeps all of these internal back and forth messages. So if I ask the question, what time is it? You can actually see in your debug view what is actually happening. Like the user is sending text content to the large language model, what time is it? Then the assistant returns with, you need to call this function with the name general plugin -getTime. Then the tool itself will get that result from that function. It will send that result back to the large language model, and then the assistant large language model will return with the current time is 1624. So it looks like we only send one message to the large language model and get the result back, but in reality, Semantic Kernel is actually going back and forth a couple of times to get that information from our own functions and to use that data to enrich the answer from the large language model. Then, very quickly, I have another example where you can, instead of run your semantic kernel using Azure OpenAI, you can also use, for example, Ollama. Ollama is a tool you can download locally, and you can basically download some models locally, smaller models, and you can run those large language models locally from your own machine. And the whole concept is the same thing. Instead of doing add Azure OpenAI, I'm doing add Ollama. This runs on my local host, and the model that I'm using is Llama 3.2, the 3 billion version one. I'm adding the same kind of plugins. I'm adding the same chat completion agent. These classes are a bit different because now I need to specify that it can automatically call functions for Ollama, which is a little bit different from Azure OpenAI. And again, these things are also the same. So if I run this, I can ask the same question. What time is it? It will take some time because it's running locally now. But it's the same concept, but now it runs locally on my machine instead of Azure OpenAI. So again, Semantic Kernel gives you a very simple SDK that is compatible with multiple of these models. And it's very easy for us developers to use it for all of those different kinds of models. The classes and the methods that we use, they stay the same. So it's a nice level of abstraction. And with that, I'm going to finalize with showing you how it's implemented in my own, my home application. So my Blazor web application has a copilot helper, and this copilot helper uses Semantic Kernel. And here you can see that it's the same concept. I have I'm also using Azure OpenAI, but the cool thing, because the kernel builder is very similar to the .NET application builders, you can also attach dependency injection on your semantic kernel. So my application uses Mediator. So if I go to the add application extension method, I'm using Mediator to basically send queries and commands to all the things that are available in my application. And by adding Mediator also to my semantic kernel, now semantic kernel also has access to my Mediator. So if I add all of these plugins, so I had general plugins in my very small example from before. Here I have listed my plugins, like I have plugins for my solar, I have plugins for my power, for my car, for my heating, and for my sauna. And if I open one of these, for example, the one for my car, you can see I have all of these functions, but I don't have any business logic because I'm already using my existing business logic by using Mediator. So I'm just injecting my Mediator in my plugin for semantic kernel, and I'm then using that Mediator inside of these functions that I all provide to the large language model. What does this mean? This means whenever I send a message using my copilot to a large language model, all of these functions as metadata are sent with that. So that's a lot of extra questions that I basically ask. But with all of those descriptions, the large language model knows which of these functions it needs to call to get that real-time data. For example, the top one gets the location where the car is parked or driving. So if I ask a question that is similar to this, it will actually call that get car overview query, and it will get the location from that. So I can show you again, if I put a breakpoint here, if I ask, for example, please make a joke about the current location of my car. It breaks because it's about the location of my car. It returns that location to the large language model, and then the large language model hopefully will have a funny joke. Why did you park your car at Populerenlaan in Willebroek? Because it's rooted in making good parking decisions. Ha! Yeah, populier, of course, is a kind of tree. That's why it's using rooted. So now it's using that real-time data from my application, live data, and it's enhancing it, of course, with what a large language model can do very good. It's using language to do all kinds of fun things. I can also do one final example, for example, please unlock my car if it is parked in Utrecht. Your car is parked in Willebroek, not in Utrecht. Would you like me to unlock it? So it's not going to unlock it because, of course, it is not in Utrecht. But if I'm just going to tell it, please unlock my car, it will actually do that. It's going to take some time because my car is in sleep mode right now, unless my wife is driving around. I have no idea. It's going to just throw her out. So now my car is unlocked. It says. So if I look at my app,
you also make the alarm go off the car.
Yeah, I can make it fart and stuff like that. So yeah, it's unlocked. I can actually, I think, if I go here, you can see the little icon here tells me that my car is unlocked. So I can click it again to lock my car back up. So yeah, I not only can ask for information about my car, I can also send commands to my car. Of course, you need to be very careful with this. A good idea when building these copilots is basically always ask for like an additional question. Like if you, please unlock my car, that then the large language model, I'm going to unlock your car, are you sure that you want to do this? And then that you have to acknowledge with, again, yes, to actually make that happen. Otherwise, it can do all kinds of crazy stuff. Yeah, but I'm out of time, so I'm just going to shut up now. Let's very quickly go back to my slides, because they asked me to show you this. If you have any feedback for me, please rate these sessions by using that link. And with that, thank you so much. I will be here if you have any more questions, and otherwise, enjoy the rest of your day.